Donc on reprend cette session avec Simon Bacon. Welcome, my friend. Please.
Wonderful. Thank you, everybody. It's good to see everybody here, and I know we're still a lot of today to go. So I'm going to talk about. This is a little bit more methodology than it is specifically physical activity focused interventions. So I give you that warning, and if there's a mad rush for the exit, I understand why. So let me just start by, I just want to say that I'm in Canada. I come from Concordia University and the CIUS Nord-Île-de-Montréal, which is where my research center is, depend upon indigenous lands that were accumulated through various different policies and mechanisms through the process of colonialization. And we live on the Kanikahagi Nation. And I'm just, one of the things that we as a group, plus a lot of my collaborators, are very committed to doing is redressing that balance and lifting the voices of the indigenous communities, and we have a variety of different activities that do that. These are my disclosures, none of which have anything to do with this talk whatsoever, but in fair cop. So what I'm going to do is my objectives are very simple today. I've got two things. By the end of this, you should be able to give a detail of what is a pilot study, what is a proof of concept study, and you should be able to contrast the use of these. Okay? And if you catch either of those two, I feel like I may have done my job at the end of it. Okay, I just randomly selected some studies to present here, more for illustrative purposes. So this is a study that was published a couple of years ago in Medicine, Science, Sports and Exercise, which is, it's one of the best sports science papers. This is a pilot randomized controlled trial. It's pretty standard. This is 56 people, randomized physical activity or a comparator. The physical activity is a series of sessions that you do both at home and in a group setting, and it runs for 12 weeks. Group sessions were well attended. And the upshot of this is that all the physical activity measures were significantly increased in the physical activity group relative to the comparator group. Okay, so it had, according to them, a pretty high degree of efficacy. Now, okay, this is a physical activity session, so I'm going to get you to do a little bit of work here. It's not very much work, but hands up, those of you that think that this was a pretty reasonable, acceptable pilot study. Don't be shy. So you've got hands up if you think it's okay. Okay, hands up if you are not so convinced. Okay, and then everybody that hasn't put their hands up yet because you're ambivalent, put both your hands up. It's physical activity. Come on, let's do this. Okay. All right. So I'm going to not give you the answer just yet. I'm going to let you figure this one out. So let's start by this fundamental question. What is a pilot study? And what is a feasibility study? And why am I talking about the two of these together? So what's a feasibility study? It's very simply, it's a study which provides information about a proposed trial. Can it be done? Should it be done? And if so, how? That's what a feasibility study is. Technically, a pilot study is a feasibility study. And what this is, it's the little mini-me of that trial, okay? So there may be aspects in a feasibility study, we can talk about what you can measure in those, that are very broad. The pilot study should look exactly like the final phase 3 randomized controlled trial that you're thinking of doing. It's the smaller version to test feasibility. And so whenever someone sets up to do a feasibility or a pilot study, the first thing I always ask is, well, what's the final trial that you have in mind that you're setting this up to answer questions about? What is not is a standalone study. There is no such thing as me just doing a pilot study for the sake of doing a pilot study. Has to lead to something else. So what are the things we should be testing? Okay, so there's 4 categories. First one's process, and this could be things like recruitment rate, dropout rate. It's creating the protocols and seeing if people understand them, getting the timing of things, and so on. Could be resource questions. Can I actually get everyone to complete my assessments the way that I want them completed? Can I get access to equipment? We did a study not so long ago that had MRIs included in them, and boy, was that a challenge, just actually physically booking MRI slots. All things that are good for feasibility and pilot trials. Management. Do I actually have the right staffing structure to deliver the final trial? If I'm thinking more than one site, do I have the capacity to onboard sites and the mechanisms in place for that? How do I accumulate data, process data? And then finally, treatments. And not does the treatment work, but this is questions about, do I have enough interventionists? Are my interventionists trained? Will patients adhere? Do they find it acceptable? Okay, these are the things that pilot and feasibility studies actually measure, or should be testing. Which leads us to effectively 4 main outcomes. There's only 4 things that you can get from a pilot or feasibility study. And it's very simple. It's continue without modification. So what you have to do is be able to set up a whole series of criteria about go, no go. Okay, so ahead of time, go, no go. And you've got option number 1. Everything went as I expected it to, go, move on to my trial. Continue without modification, but closely monitor. So it wasn't 100% perfect, but it was pretty good. I think I know where the issues are. I can keep rolling, but I need to be cautious. Continue, but modify the protocol. Okay, so it didn't quite go to plan. We understand why it didn't go to plan. We've developed a solution. We've got some sense that this solution is going to work. Maybe we tested it as a sidebar. So I feel confident I can move forward with that changed protocol. And then the thing that none of us like to think about, but actually is a completely legitimate option, stop. This pilot and feasibility study showed me that fundamentally we have a problem. We should not move forward. So that's just a pictorial, just to remind you that a pilot study is just part of this broader array of feasibility studies. And what makes a pilot study unique from all other feasibility studies is that it ultimately is testing an aspect of randomization. Okay, so the willingness of participants to be in the comparison group, the potential for unintended crossover, adherence to both arms. That's the sole unique element of a pilot study relative to every other kind of feasibility study. And once again, it's the smaller version of that final project. What it is not is a less expensive way to assess efficacy. However, if you, like that very first study I just showed you, if you do a scan of pilot studies, I can guarantee you that at least 90% of those studies are going to talk about efficacy outcomes. Certainly not a guarantee that the full study will be successful or positive. What we know about small-scale, poorly powered studies is that they tend to not actually translate when they're then reproduced on a larger scale. That's true universally. And by the way, everything I'm saying here about pilot and feasibility studies is not specific to behavioral interventions, not specific to non-pharmacological interventions. This is universal elements. And the other thing I'm not going to talk about, I'm just going to drop this one and sort of walk away, and we can have a conversation later about it, is that they are not effect size estimates for a full study. There's a whole reasons why anything that if you were to measure any kind of efficacy outcomes, they make very poor estimates for final trials. Okay, so I'm going to contextualize this. So many of you, I'm probably, because it's a European audience, probably use the MRC model when they start thinking about how they develop behavior change or non-pharmacological interventions. I personally, because I'm on the other side of the pond in Canada, are very much attached to the orbit model. They're very similar. So what we're talking about is this little box here, okay? And it's part of this continual process of how we develop, test, and evaluate our interventions. And just to say, I started with doom and gloom with this particular piece, but actually, there's some really good studies out here, and this is an example of a really good one. This is truly a pilot study, three arms of this study, a family intervention, a pedometer only, and then a treatment. It's 52 weeks. They had good retention. They tested things like children liking the intervention. They had measures to show people's engagement in physical activity. And the upshot was that they managed to demonstrate the intervention was feasible and acceptable. The trial could be done. Most of their criteria, because they had a whole series of criteria about no-go. And that really, and this is great, and we need to move forward to do now the full trial. We have enough signal here that it's worth it. Not one single mention of efficacy, not one single mention of saying this worked. This demonstrates that this intervention is ready for prime time in any way, shape, or form. Okay, so a lot of us talk about pilot studies, and I've just shown you how we probably incorrectly talk a lot about pilot studies. So then begs the question of, how do I go about understanding if my intervention's a good intervention or not? How do I know that I've got something that should move down that pipeline? And here it's just taking one step back. This is a proof of concept study. This is a terminology we do not use very often in our language of how we develop and test our interventions. But we really probably need to do this more often, because this is what the vast majority of the work that we do is actually where it's actually situated. So where's proof of concept study? Really here what you're trying to do is identify that a treatment can have a clinically significant signal. And I use that from a context that most of my work is done clinically, but this could actually translate to any kind of particular outcome, and trying to shift that outcome to enough that it's actually going to have some impact in the context it's being tested. Importantly, this can be done completely on its own. You don't need randomization for this. Sometimes you may deem that it's interesting, so you could do it in relation to a comparison group. But certainly as a first step, I can take my intervention and I can test it, and without even having a comparison group, I want to know, does it actually shift my behavior at the very least to a point where I feel confident that that's going to have some importance later on. If I can't even do that, irrespective of a comparison group, who cares about what it looks like against something else? And I'm not talking about a statistically significant change. I see lots of studies that show statistically significant changes that have very little translation to any reality. Getting people to exercise 10 minutes more, 5 minutes more across a week, clinically, very questionable. You can also use this to test things like adequacy of comparison groups, which is really important as well. That's something we don't do very often in our field either. And it gives you an opportunity, and this goes back to some of the conversations we've had throughout the day about the question of implementation, about the translation of all this great work to be able to then protocolize it and have other people take it on board. Proof of concept testing is absolutely a fantastic place to start building that stuff out. How do people actually do the intervention? We have lots of work where people in their own space do very well at delivering that intervention, but no one else can repeat it. Here, as I said, you can focus on behavioral outcomes predominantly. Statistical significance is not important. When we build proof of concepts, we're really looking at the proportion of people that we can get to meet a certain level, which is the minimally clinically important difference. Okay? I want to know, can I get 70-75% of my population to actually shift a behavior enough that it's actually going to be important and matter? Do researchers do this? Yes. So here's just had nothing to do with this, but it is a good Canadian Montreal example. This is a trial of personalized virtual exercise in lymphoma survivors. And in this, sorry, let me just take a step back. They actually did a single-arm proof of concept study. Okay, 20 participants just managed to demonstrate that they could engage these individuals, that they could get them actually being physically active sufficiently so that they could then, feel like if they can continue that physical activity, it would translate into clinical benefit. They then moved that on to actually do a pilot randomized control trial of that intervention, where all their outcomes were go, no-go outcomes. Can they actually recruit enough people? Could they actually get sites to deliver the activity, et cetera, et cetera? And the upshot of that paper was, it's promising, but we certainly need a fully powered trial to make any real claims about it. So I'm giving you snapshot examples of probably how we should be building our science. And we talked a lot about evidence, building an evidence base, and if we want to be taken seriously and have things embedded, these are the kind of steps we really need to go through to be able to make sure that we understand our interventions, that those interventions are built and tested appropriately, and that we have a really solid evidence base. So, coming back to my objectives, detail what pilot and proof of concept studies are. So just to remind you, pilot study, it's tied to a specific trial. It's asking questions about feasibility, specifically around randomization. Proof of concept, all about the intervention. Does it work? Okay. Contrast the two. Hopefully I've identified when to use them, what kind of outcomes are different between them, and hopefully you can go off and do this in a more broader perspective. Finally, an unabashed plug. So something that Greg was fundamentally part of at the very beginning, over 10 years ago now. We started the International Behavioral Trials Network. We have a meeting coming up in May. It is very methodological, so if you're a methods geek, this is fantastic. We do cover more conceptual pieces beyond just methods. It's in beautiful Montreal. If you want to become part of the network, feel free to join it. It's a very expensive network, all of $0 that you have to pay for that. And then we have a Canadian version of it, which is CBITN, which I just wanted to flag. And finally, that's just part of the amazing team in Montreal that helps make this work possible. And wanted to thank our sort of co-investor, Kim Lavoie, who co-directs the Montreal Behavioral Medicine Center. And thank you very much.
To ask some questions.
Hey, yeah.
Maybe could you explain more what is MCID and what is very, very important, especially for non-pharmacological intervention?
Yeah, this is a great question. What's a minimally clinically important difference? So, one of the things that becomes really important is how much do we need to shift a behavior to make it worthwhile doing? That's effectively what we're talking about in terms of minimally clinically important difference. For certain areas, physical activity, there's a big debate around what that should be, but you could take public health measures of 150 minutes of MVPA per week. You could take evidence-based measures of 75 minutes, which has a stronger evidence than 150, or you could take things like increases in 30 minutes. All of those three measures in epidemiological work, in other intervention work, has been translated to significant improvements in a variety of diseases and a variety of disease outcomes. Okay, so in physical activity, it's really nice. It's really clear. There's some really good clear examples. So I don't have to worry about, in my early phase work, changing cardiovascular disease, changing cancer risk, changing diabetes risk, because I already have a proxy measure that's built around my behavior that I'm trying to change. So I can focus on doing a study that can demonstrate I can change that behavior enough. In early phase, that's what we need. Ultimately, whatever my intervention is, I need to put it into that phase 3 trial, and that phase 3 trial needs those clinical outcomes. Where it becomes a little tricky is in a lot of our areas, we don't have MCIDs. And I have a lot of people come up to me and be like, I just don't know what my MCID is, so what do I do? And it's a great question. What it means is, if you don't know what your MCID is for your behavior, you're not ready to do an intervention. That's a pretty harsh comment, I think, but I think it's a fair comment. I think what you need to do is you need to go away. We've got epi data, there's probably, some evidence synthesis work that needs to be done and so on. So you can get a sense of how much do I need to shift this behavior? If you don't know how much you need to shift a behavior by, why are you creating an intervention to shift it? So that's, and that clinically, it becomes critically important because that will be the thing that when you go to that final trial, it will create the probability that this will actually work, and therefore people down the line will actually take this on board because they'll go, hey, this actually made a clinical difference.
Last but not least, what about your training session in May and with Kim and your huge grant to invite especially young researchers on behavioral science? What is this event and why you have to come to Montreal for this event?
Okay. I paid Greg to ask that question, so I'm glad no one else asked any questions. Okay, so sorry? I'll go back to the slide. Yes, I can go backwards. There we go. Yeah. Shameless plug. So IBTN's sole sort of, it was set up and it kind of parallels a lot of the work that Greg's been doing, including with NPIS, in trying to get people on board with doing their science more rigorously. There's no perfect way of doing this, but at least we can be more rigorous. So there's very heavy emphasis around methodology. How do we do our stuff? And as you see, is my presentation. I'm a bit of a methods geek, so I kind of think that stuff is important. IBTN, there's sort of two components that we have. One is the conference part of it, which is really bringing international experts to sort of talk about these elements, talk about how do we do this, how do we do things like integrate behavioral science into public health, how do we start tackling the issues around the digital innovation pieces. So, Mo set me up very nicely from the earlier session. They're the kind of things that we tackle, but on a very high level in terms of what should we be collectively doing as a field and how should we be doing this together. In addition, we have a whole training piece of it as well. So, unfortunately, the summer school that we run, that happens the week beforehand, we've closed applications for that. However, all the training components, we have a series of modules that go through and tackle these kind of questions about how do I set up a good research question, how do I test it, how do I develop my intervention, what are the things I need to worry about, how do I engage the key knowledge users. We've actually put all of those online. So the CBITN website, even though it's Canadian, anybody can go there. We have them in English, we have them in French, and you can go watch those modules for free. You can pick and choose what you see, and they're really helpful in terms of that process of increasing knowledge.
Thank you very much. So maybe thank you pour avoir traversé quand même l'Atlantique pour venir. Merci également à Kim d'être là. Vraiment, c'est un honneur à chaque fois de vous recevoir. Et si vous voulez bien, donc on l'applaudit et on va appeler Guillaume Talon. Merci encore.